Class 8, welcome. We are on the chapter matrix. Now, today we start determinant of a matrix, singular and non-singular of a matrix. What we have studied up to now is multiplication of a matrix by a scalar. Today we start determinant of a matrix and singular and non-singular matrix. Let's see what is determinant of a matrix. Determinant of any matrix is the value of that matrix. Let's find. How do we find determinant of any matrix? Let me take an example. Determinant of matrix A. Determinant of matrix A. First of all, how do we represent the determinant of matrix A? So, how do you write? So, determinant of matrix A. Determinant of matrix A is written as, just you write like this. This is called the determinant of matrix. Or in shortcut, you can write DET, determinant of matrix A. Determinant of matrix A. Okay. We use delta also. So, what is determinant of matrix A? Determinant of matrix A is the value of the matrix. Let's take an example. If I take A is equals to A11, A12, A21, A22. We can find the determinant of only square matrix. Determinant of square matrix here. Here we are finding the determinant of square matrix. So, in case of we find the determinant of square matrix. Okay. So here we are finding the determinant of matrix A. How do you find? A11, A12, A21, A22. Just to cross multiply. So A11 into A22 minus, when it goes up, it will be minus A21 into A22. Yes, this is its value. This is its value. This is the determinant of matrix A. This is the determinant of matrix A. Sorry, here is the determinant of matrix A. So I take the here. This is the determinant of matrix A. Determinant of matrix A is this value. Let's take an example here. So if I take matrix B, 1, 2, 4, 8. Okay, 4, 8. Then what is the determinant of matrix B? Determinant of matrix B. Determinant of matrix B will be equals to 1, 2, 4, 8. Down and this is up. Will be equals to 1 into 8 minus 4 into 2 is equals to 8 minus 8 will be equals to 0. Okay, and let us take next matrix. These are 2 by 2 C, matrix C. 3, 4, 5, 6. 3, 4, 5, 6. Let us find the determinant of matrix C. Matrix C is equals to, write the elements in between these two parallel lines and give the cross sign, and is equals to, now you multiply 3 into 6 minus 5 into 4, 18 minus 20 is equals to 2 minus 2. So in this way we find the determinant of any matrix. In this way we find the determinant of any matrix. Generally we find determinant of square matrix. Either it is of 2 by 2 or it is of 3 by 3. Okay. So here we have found the determinant of square matrix. Okay. A matrix B and matrix C. I have taken examples of matrix B and matrix C, and we have found the determinant of matrix. Now This is so. What is how do you represent? Simply you write two parallel lines. In between two parallel lines you write A. This is called determinant matrix A, or det A you write. Delta also is used here to represent the determinant of any matrix. So if a matrix is given here, matrix A is given here, we have found the determinant of matrix A in this way by cross multiplying a diagonal element. Yes, and I have taken matrix B. I am taking here the numerical value, and matrix C also. I have found the determinant of matrix B and matrix C. Now, what we have understood, what do you mean by determinant of matrix? Determinant of matrix is nothing, the value of the matrix, the value of this matrix. So this is the determinant of matrix. Now comes the case of singular or non-singular matrix. How do you identify? How do you identify whether the matrix is a singular matrix or non-singular matrix? Non-singular matrix. How do you identify whether the matrix is a singular matrix or non-singular? Take any matrix. Let's take this example here. Let's take matrix B. If here is the matrix B I have taken, I have found to know the singularity or non-singularity of a matrix or non-singularity of a matrix, you need to find its determinant. So on the basis of determinant, you can see whether the matrix is a singular matrix or non-singular matrix. So here I am taking examples, matrix B, matrix C. I have found the determinant of matrix B. Matrix B is 0, and here matrix C is not equal to 0. So what we know, that if the determinant of any matrix here, if the determinant of matrix C is 0, so this is a singular matrix. This is a singular matrix. Singular matrix. Which singular matrix? C, the singular matrix. And if determinant matrix B is not equals to, sorry, C is not equals to 0. C is determinant of matrix C is not equal to 0. So C is a non-singular matrix. Determinant B is 0. So singular matrix. So how do you identify the matrix is a singular matrix or non-singular matrix? If the determinant of the matrix, is not equal to 0, if the determinant of matrix is any matrix is not equal to 0, non-singular matrix. Not equal to 0, non-singular matrix. Thus, whether the matrix is a singular matrix or non-singular matrix, on the basis of its determinant, we can say the matrix is a singular matrix or non-singular matrix. How? If the determinant of any matrix is not equal to 0, non-singular matrix. Not equal to 0, non-singular matrix. Equal to 0, singular matrix. Not equal to 0, non-singular matrix. Equal to 0, singular matrix. So, if the determinant of any matrix is equal to 0, it is a singular matrix. If the determinant of any matrix is not equal to 0, it is a non-singular matrix. So, I have completed here some theories before this exercise. So, now I will be starting example problems and exercise problem, and I shall complete this exercise today. Now, I'm going to do this all. Now come to your book. Come to your book, example number 5. Example number 5. It has asked to find the determinant of the given matrix. Let me write. The question is like this. If P is equals to 3, 4 minus 2, 5 and Q is equals to 2, 1 minus 1, 3 comma, find the determinant determinant of 3p minus 4q. Yes, this is your question. This is your question. This is your question. Now, let's solve this. Solution. First of all, write what is given. So p equals to, what is that? P is equals to 3, 4, minus 2 and 5. What is q? Q is equals to 2, minus 1, 1 and 3. Okay. Then what is to find? Next step, what is to find? To find, underline, determinant. Determinant of 3p minus 4q. Now, before finding the determinant of 3p minus 4q, we need to find what is 3p minus 4q matrix. So let's find. Therefore, 3p minus 4q matrix will be equals to how much? Will be equals to how much? 3p minus 4q matrix will be equals to how much? Okay, let's write. 3 is 3. What is p? P is 3, 4, minus 2 and 5. What is q? Q is 2, 1, minus 1 and 3. Let's multiply. You are multiplying a matrix by a scalar. So 3 3s are 9, 3 4s are 12, 3 2s are 6 and 3 5s are 15. Now 4 2s are 8, 4 1s are 4, it's minus 4, and do not multiply by minus, leave the minus sign as it is, and others you use, okay? Here, this is minus sign. So 4 3s are 12, 12. Now both are of same order, so you can add this or subtract. So let's subtract this, how much it will be. So 9 minus 8, 12 minus 4, minus 6, minus sign here and minus is bracket here, and 15 minus 12. So finally you can write the answer directly also. 9 is equals to 1, this means 8, this means minus 1 is plus means this will be minus 2 here, and yes, directly I am writing the answer. I have found the value. Here I have found matrix this 3p minus 4q. Now our intention is to find the determinant of 3p minus 4q. And therefore determinant of matrix what? 3p minus 4q is equals to, so how much? 1 minus 2, 8 and 3 and up. So you can find determinant here only, or otherwise let's multiply. 1 into 3 minus 2 into 8. 3 plus 16 equals to 19. 19 is our answer. So 19 in this way. In your notebook you have to solve very fairly, write the given information, then what is to find, then start and then do it stepwise. So this is your answer. This is your answer. Okay. Go for next. Okay. Your book question only, but I am taking this question. Two questions are there in case of transpose. The question is related to transpose. So I am saying this question in my own words. Prove that, first of all, prove that the transpose of a matrix is the matrix itself. 1 number question here. Prove that already I have taught this, again I am repeating. Prove that the transpose of a matrix is matrix itself. Prove that the transpose of a matrix is matrix itself. So let's take our own example and prove this result. Solution. Let A is equals to matrix A is equals to, I will take very small example, 1, 2, 2 rows, 1 column. Then, therefore, what is the value of A transpose? A transpose means first row will change into first column. So first column here we are writing in row form 1 and 2. 1 row, 2 column, A transpose. And therefore A transpose, what is the answer? Let us put transpose. What is A transpose? A transpose is this one. A transpose matrix is 1, 2. Its transpose. A transpose value is 1, 2. इसको बनी transpose. So first row will change into one row will change into, it has only one row, so row will change into column. It's a row matrix will change into column matrix. So 1, 2, 1, 2, it has 2 rows, 1 column. Finally, what we have got, our A matrix is 1, 2, 2 rows, 1 column. A transpose is 1 row, 2 column. Transpose of matrix A is matrix itself. So this is matrix A itself. So to prove that the transpose of a matrix is matrix itself, A transpose is AT transpose is A. So transpose of any matrix is a matrix itself. So this is proved. So let me take next theory, next question here. Okay, now let me go for next question. Okay, this question also it is given in different books or practice books. I am taking this question in language form. So see the question. Prove that the transpose of sum of any two matrices is equal to sum of their transposes. These are question. Prove that the transpose of sum of any two matrices is equal to sum of their transposes. Let's verify this result. Solution. Let I would like to take your books example only questions here, matrix A and matrix B, and I will verify and I will show you. Let matrix A is equals to, let us take, so in book is 1 0 3 question and 2 minus 1 1. Okay, this A matrix they have taken, and matrix B, let us take another matrix. This is, it has 3 rows and 2 columns, and it is 0 minus 1 and 0 3 2 and minus 3. Okay, these two matrices I have taken. It also has 3 rows, 2 columns. To prove here is A plus B transpose is equals to A transpose plus B transpose. This is our requirement. This is to prove. We need to prove this. Transpose of sum of two matrices equal to sum of their transposes. These are question. I have taken two matrices as an example, and I will verify this and I will show you. Now let's go. First of all, let me find value of this left hand side part. So directly also can do. First of all, let us find A plus B. So let us find first of all A. What is the value of A plus B matrix? So what is A? A is 1, 0, 3, 2 minus 1, 1, and B is 0 minus 1, 0, 3, 2 minus 3. Okay. They have the same order, 3 rows, 2 column, 3 rows, 2 column, so their addition exists. So let's add them. So 1 plus 0, 2 plus 3, 0 minus 1 plus 2, 3 plus 0, and 1 minus 3. So it is 1 plus minus 3. It is same. Okay. So now, what is the value? The value is 1 minus 1, 3, 5, 1, and here minus 3. Okay. So plus minus minus, so it is minus 2. So 3 rows, 2 column. And therefore I want A plus B transpose. So A plus B transpose value, rows will change into columns. Rows will change into columns. So 1 and 5, minus 1, 1, and 3 and minus 2. 2 rows, 3 column is the value. A plus B. We have found the value of A plus B matrix. A plus B matrix is this one, and transpose of A plus B is this is the result. Let's find this one now. Okay, let's find this one. Okay, here from here I am doing. And therefore, right hand side part. Okay, you can see this right hand side part. That is left hand side part, no problem. Otherwise, you can do right hand side part is A transpose plus B transpose. What is A transpose? Write the matrix A. A is 1, 0, 3, 2 minus 1, 1. Its transpose plus, what is B? 0 minus 1, 0, 3, 2, 3. Its transpose. Now, do its transpose. This first row is in the first column, 1, 2, 0, minus 1, and 3, 1. 2 rows, 3 column, plus its transpose. Row in change into column, 0, 3. Second row, second column, minus 1, 2, and 0, and 3. Okay, 2 rows, 3 column. Let us add now. 1 plus 0, 0 minus 1, and 3 plus 0. 2 plus 3 minus 1 plus 2, and 1 plus 3. 2 rows, 3 column. Right. So finally we get what we get: 1 minus 1 and 3 and 5, 1 and 4. 5, 1 and 4. 2 rows, 3 column. 5, 1 and 4. Where is the mistake? When we have 1 minus 1 and 3, 5, 1 and minus 2, it is minus 4 here. So matrix, let's check the matrix. Oh, here is minus 3. Here is minus 3. Here is minus 3. This is minus 3. This is minus 3. Third row, this is minus 3. So this is minus 3. Now this will become minus 2. So we are getting the same result. So that's why therefore A plus B transpose equals to A transpose plus B transpose. Proved. We have the same result. That's why we have proved this. Prove that the transpose of sum of any two matrices is equal to sum of their transposes. We have taken examples and I have proved this. These are very important questions. Generally, this type of questions are asked in examination or in entrance also. Okay, go for exercise. Exercise 2.2. You can do all problems. Exercise 2.2, you can do all problems. Question number 1, which of the following matrices can be added? You check if they have the same order, then they can be added. If they do not have the same order, if one is of our two matrices have two different orders, then you cannot add or you cannot subtract. Okay, go for next. Fine. Question number 2. Find the following matrices on the basis of matrices given in question number 1. Find the following matrix on the basis of the matrix given as just it is given what questions are given in matrix 1, just to add and subtract. In question number 2, so it is just addition and subtraction. You can do addition and subtraction. Okay. Question number 3. Question number 3 is you need to find the values of x and y. So it's nothing. Just you add, equate, you get the values of x and y. Okay. I will solve one of the questions and I will show you. Now see. Question number 3. Question number 3, 4, 5 all are same. Question number 3, 4, 5 all are same. So I would like to solve two questions. I will solve. Okay. Here. I will drop this one. This is not needed. Okay. Let's go. Let's go to question number 3. Question number 3. Solution. To find, first let's divide this board into two parts. It will be easy for us to write. Okay. To find is underline values of M, N, P and R. Okay. Now, what is given to us? Given to us is that 4, 4, M0 is equals to NP 3, 4 plus 2, 3, 4R. Okay, this is question. We need to find the value of M, N, P and R. Just nothing is there, very easy question. Just you add and equate both sides, you get the values of M, P and R. Okay, or now this keep it as it is 4, 4, M and okay is equals to, this is how much? N plus 2, this becomes P plus 4, 3 plus 3 and 4 plus R. Now these two matrices are equal matrix. Equal sign is here. These matrices are equal matrix. It has 2 by 2 order. This also has 2 by 2 order. Since the matrices are equal, their corresponding components, their corresponding elements also will be equal. So you get the result. So you write here, since the matrices are equal, so their corresponding components are also equal. So let's equate. So 4 will be equal to, the value of 4 will be equal to first row element lying in first row first column will be equal to the element lying in first row first column of right hand side, n plus 2. So therefore, or you can say 4 minus 2 equals to n. Therefore, value of n is equals to 2. One line you draw. You got the value. Now equate this and this. 4 will be equals to p plus 4, or 4 minus 4 equals to p. Therefore, value of p equals to 0. Correct. Draw next line here, small line. This one completed. This. Let's do this one. So here m is equal to 3 plus 3. Therefore, m is equals to 6. Okay, this also we have done. Go for this. 0 equals to 4 plus r, or 0 minus 4 equals to r, therefore r equals to minus 4. So we have got values of all. Therefore the required values of m is equals to 6, n is equals to 2, p is equals to 0, and r is equals to minus 4. Answer. This is your solution. Go for next question. Question number 5. Question number 5 of your book. Okay, solution. Question at last I'll give you in that video. You will see the questions. Okay. Question number 5. Similar question, very easy. To find here the values of x, y, and z. Okay. Now, since what is given to us? 3x minus 2, 5y plus 4. This value is 2, 4 plus 2z is equals to x plus 2, y minus 4. This is 2, this is z minus 2. Okay, this is given to us. You need to find the value of x, y, z. Again, these two matrices are equal matrices. So we can equate and we can find the values. So let's equate and let's find the values. Okay. Since the above matrices are equal matrices, so their corresponding components are also equal. Okay, so you can write this over here also. Let's equate. So first row, you may try in first column of left hand side matrix. You may try in first column of right hand side matrix. So the value is 3x minus 2 equals to x plus 2. So how much? 3x minus x. This bring this side and 2 plus 2, or 2x equals to 4. Therefore, value of x equals to 2. Draw one line here. Yes. Go for next. Let's go for y. 5y plus 4 equals to y minus 4, or 5y minus y equals to minus 2 or minus 4, or 4y equals to minus 8. Therefore, value of y is equals to 4 to the 8, so minus 2. Go for the last one, that is 4 plus 2z equals to z minus 2, or bring this side 2z minus z equals to minus 2 minus 4, or z equals to minus 6. You can see directly that is the z equals to minus 6. Therefore the required values, therefore the required values of x is equals to 2, y is equals to minus 2, and z equals to minus 6. Full stop. This is the answer. So that was question number 3 and this is question number 5. So write very properly how I have written. After completing this solution, just double underline it and close it. Double underline and close it and write very properly how I have written. First write what is the given information, then write what is to prove, and then solve it very properly. It must be very neat and clean. So go for next. Question number 5 also I have completed. Now there are 11 questions altogether. Question number 6. Question number 6. M and P matrices are given to you. Find matrix A in the following conditions. There is nothing. Just you add, you will get the answer. If you want me to solve this, then there is nothing. You can solve yourself. Just you put the value, just you add the matrices, you will get the answer. So question number 7. Question number 7 and question number 8, it are their same variety. Same variety. No, I am solving it. No, come here. Okay. Question number 7. Question number 7D. Here I am solving question number 7D. Solution. So what is given? Given is matrix A is equals to 2 0 1 3 minus 2 4. Okay. Matrix B is equals to 1 0 0 4 minus 2 3. Okay, is given. To find, what is to find? What is to find? Underline. What is to find? To find is 3A minus 4B value. What is the matrix 3A minus 4B matrix? So this is asked to find. Previously also we have solved like this question. So again I am solving and I am showing you. Okay, this is our question. Let me do the solution. So now, okay. Now see. Okay. 3A minus 4B matrix will be equals to 3 times matrix A. 2 0 1 3 minus 2 4 minus 4 times what is matrix B? 1 0 0 4 minus 2 and 3. So 3 2 are 6, 3 0 are 0, go on multiplying, 3 1 are 3, 3 3 are 9, and minus 6 is 12. Okay, minus, multiply this, 4 1 are 4, you want to multiply with minus sign, leave the minus sign, 4 zeros are 0, 4 zeros are 0, 4 4s are 16, 4 2s are 8, and 4 3s are 12. Okay. Now since they have, both the matrices have the same order, 2 rows by 3 columns, 2 rows by 3 columns, so we can subtract it, so subtract. So 6 minus 4, 3 minus 0, minus 6 minus 8. Okay. 0 minus 0, 9 minus 16, and 12 minus 12. Okay. 2 rows, 3 columns. You can write, otherwise if you don't want to write, don't write, no problem, it's no difference here. So it is 2, this is 3, this will be minus plus, so it will, value will be 2, this is 0, this will be minus 7, and this is 0. So this is the answer. So this is your answer. This is your answer. It is very easy, just you add, subtract, you get the answer. Okay, no problem. Go for next. Question number 7 also I have solved. Question number 8. 8 is same. Prove that. Just you put the value. You will get all the matrices 0. So 0 means a null matrix. All you will get, all values you will get 0, 0, 0, 0. So So it is a null matrix, and null matrix is given by O. O is a null matrix. Okay. Here, null matrix is given by O, capital O, where O represents the null matrix. So this is question number your 8 number. Come to question number 9. Question number 9 is asking you to check whether singular matrix or not. Find a singular and non-singular matrices. So if determinant is 0, it is singular. If determinant is not 0, it is non-singular. One question we have already solved. I think so. Yes, I have one question. Question number 10 also you can solve. Question number 9, one question I will solve, and I go for question number 11. Let's go for question number 9. 9 also we have solved. Question number 11 also I have solved. 11A also I have solved. B also I have solved. And 11 number C, K times this, you can do yourself. Now see question number 9. Find a singular and non-singular. Just you need to check whether the matrix is singular matrix or non-singular matrix. To find the singular and non-singular matrices. Okay. There are 4 matrices given to you. Out of 4, which are singular and which are non-singular. Just to find the non-singular and non-singular, you need to find its determinant. So just I am taking here. I will do 2 problems. Question number A, solution. Matrix. What is the given matrix? Matrix is equals to here 9, 3, 6, 2. Okay, this is 2 by 2. Now, let's find determinant 9, 3, 6, 2. Determinant of this will be equal to 9 into 2 minus 3 into 6. 18 minus 18 equals to 0. Oh. The determinant of this matrix is 0. It is a singular matrix. Since determinant of this matrix is equals to 0, so the given matrix is a singular matrix. You can write determinant of matrix. Singular matrix. Go for next. Now question number D. D number question. What is the matrix given here? Matrix is equals to 5, 7, 9, 4. 2 by 2. 2 by 2. So this is the matrix. Now check whether it is a singular or non-singular. So let's find determinant. 5, 7, 9, 4. Just to cross multiply, 5 into 4 minus 7 into 9 is equals to 20 minus 63 is equals to minus 43. Since determinant of matrix is not equal to 0, so the given matrix, that is 5, 9, 7, 4 is a non-singular matrix. It is a non-singular. Okay, it is a non-singular matrix. So question number 9, they have given you 4 matrix, and you will check whether the matrix is a singular matrix or non-singular matrix. Come to question number 10. Question number 10 already I have solved. 3 matrices are given to you, A, B, C. You need to find a determinant of 2A plus 3B, 4B, and like this question, you already I have solved these questions in the beginning only. Come to question number 11. Question number 11, last question. Question number 11, A and B already I have solved. The transpose of a matrix is the matrix itself. Question number B. B is the transpose of sum of 2 matrices equal to sum of their transpose. This also I have solved. And question number C, 11C, last question of this exercise. This I am going to solve for you. That is question number 11C. Last question. Number 11C. Now see. Question number 11C. C number question. Okay, C number question. 11 C number question. What is given to you? Matrix A is given to you 1 minus 3 0 2 6 1. What is matrix B? 0 5 1 3 7 minus 4. 3 rows by 2 column, 3 rows by 2 column. I have written this, is not given in book. So next, scalar value is 3. Find A and B, matrix A and B, proving the following relations. Okay, to prove, what is asked to us is, we need to prove that is K8 times, transpose of K times equals to K times A. This is our requirement. This is our requirement. So, if you want directly, then directly also you can solve. Okay, this time let us solve directly. I will give you a small bracket. Instead of giving this large bracket here, because I am going to use another bracket also. So that's why. Now see, let's solve it. So directly I am solving. Left hand side, different side is KA dash. So here, now I am using this curly bracket, and what is K? K is 3 times, what is A? A is 1 minus 3, 0, 2, 6 and 1. Okay, times transpose. Okay, transpose, it has written in this way. Let's write this, a transpose. So first you multiply the scalar. So how much? 3 1s are 3, 3 2s are 6, 3 3s are 9, it's 0, 18, 3. Okay. Transpose, still transpose. Let us do the transpose. First row changes into first column, minus 9, 18, 0, 3. So 2 rows by 3 column. 2 rows by 3 column. And let us go for right hand side. What is the right hand side is KA transpose. What is K? K is 3. What is A transpose is 1, 2, minus 3, 6, 0, 1. Okay, it's transpose. So first of all, let us do start. First row will change into first column. First row will change into first column. 0, 1. Okay, I have changed the transpose. And now you multiply with this scalar. 3 1s are 3, 3 to the 6, minus 9, 18, 0 and 3. The result is same result. So KA transpose equals to K times A transpose. We have proved this. We have proved this. Now homework assignment. Now homework is to solve all exercise 2.2 with examples. So now, okay, thank you. Now see the questions here and then do homework. Okay, here I am giving you the questions to you. So Now come this side. Okay, next page. Now we have already studied this. We have solved this problem also. So come to next page. This also question number 1. Example number 6 also I have done by taking my own example. Now go to exercise. See the exercise very properly. And do these all exercises. Very easy questions. Okay, go to next page. Last page here. Okay. Okay, thank you.